Okay, this is lab 4 for Physics 2211 on oscillations. So the purpose of this lab was to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. The models I used was a video analysis software called Tracker that allowed me to track the object's position over time accurately, as well as a computational simulation using GlowScript and Python. The principles used in this experiment was Newton's second law of motion, as well as the energy principle. And to preview the results, there were minor discrepancies between the observed and computational models that we will go over later, why those could have happened. So here you can see the system and its surroundings. The system here is basically the mass, the spring, and the earth, because we are looking at the energy of this system, and then the surroundings is basically nothing. So this is the graph of the observed motion that I gathered using Tracker and tracking the object's position over time. You can see the object's initial position for both the x and y direction, and how it changes over time. This is the code for the computational model. Here I inputted the object's mass as well as the initial position and velocities. You can see the velocity was 0 in all directions initially, and then here we also input the gravity and the spring constant, as well as the relaxed length of the spring that we calculated, and the rest of the variables for the system energies. This big while loop calculates the change in energy of the system between each time point. And then here you can see the difference between the computational model as well as the model built using Tracker, and you can see that there are discrepancies here, and that the experiment model shows a less variation of the change in energy than the one using the computational analysis. So some of the sources of error could include work done from outside surroundings, because we did have the assumption that this was an isolated model, but because this was in real life, there could have been work done from outside surroundings. And another source of error that could have happened was inaccurate placement of the center of mass of the object on Tracker, that might have made the motion plotted a little inaccurately. And then here we're going to talk about the energy principle and Newton's second law of motion. So Newton's second law states that the system's change in momentum is proportional to the net force applied, and the energy principle is basically the system's change in energy is a sum of work done by surroundings and thermal energy with the surroundings. Here, by looking at this graph, is the energy principle satisfied in our experiment? Yes, it is, because no external forces affect the system, and the change in energy must be 0, and you can see that it is 0 by this line here. The total change in energy is constantly 0, while the separate energies do vary. They always balance out to 0.